Hello students. So in today's session I'll be discussing about the Apache Hadoop Yawn. Of course a very important topic, because when I talk about this particular concept, when I say Yawn, it is yet another resource negotiator, wherein this particular point plays a very critical role in working with the cluster, working with the Hadoop architecture and the HDFS. How well you are trying to work with that? Well, we are trying to provide a new version to it, an extended version where it can have much more flexibility, okay, much more advantages rather than the Hadoop 1.0. Well, this is also called as Hadoop 2.0. Okay, Hadoop 2, what do you call it as? So when we talk about these particular points, we need to understand what exactly Yawn is doing. Okay, now what was the earlier point? We had certain disadvantages. Yes. Now what was the certain disadvantages about the MapReduce was we had to work out with the scalability. Okay. So when I say scalability, you are supposed to go on adding the nodes and it has to work on it, right? But it was not keeping track of all the particular nodes. Even if there were certain nodes which were active or inactive, well, they were not actually monitored. Okay, no proper monitoring was done in the previous part of it, that is the MapReduce 1 or Hadoop 1.0. Okay, so that was the initial point. Well, when you are working with the cluster point of view, okay, we need to keep track of each and every particular node which is present in the environment. Okay, we need to check because it is a very vital component to be taken care of. So based on that, the first disadvantage which we need to work out here was regarding the scalability. Of course, here there is a change. Okay, we will just talk on this particular line, that is working towards the scalability. Okay, and later I will be discussing some more points related to the advantages and the disadvantages and how exactly Yawn makes it much more popular when you talk about the following concept. Now, when I say this Yawn, yet another resource negotiator, okay, we can have it with lot more features. Okay, not just with one particular feature of MapReduce. Because the earlier concept when we spoke about it, that is regarding towards the Hadoop 1.0, the MapReduce concept, we had to work with only one, that is a batch processing concept. Well, not in this particular point. Here, we may be having, not we may be, we are having much more frameworks which can be populated with the help of Yawn. Okay, so we'll just check all these points and we'll check the major workflow of Yawn, how it varies. Okay, what is the major part you have to take care. So the Yawn architecture will be discussed. We'll talk about the components involved in Yawn, and also a very important thing, that is how exactly the 8 steps will help you to understand the Yawn architecture. That is what is the point you have to make a note of. Okay, now we'll move on with the first, that is Apache Yawn, yet another resource negotiator. Is the resource management layer of Hadoop. The Yawn was introduced in Hadoop 2.x, basically 0, 1, it goes on upgrading, so it was called as 2.x. Okay, next, Yawn allows different data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process data stored in HDFS, that is Hadoop Distributed File System. Well, now looking at this particular diagram and what all things it allows, we have to make a note of it. Well, it says that data processing engines like graph processing. Okay, so we talk about the graph processing. Okay, so GIRAF. Okay, that is the, what you can say, framework which is used to perform or work on the graph processing concept. Then we have the interactive. Okay, for interactive we have so many. Okay, streaming and all those particular point is there. HBase online. Then stream processing itself is having Storm S4. Okay, and of course the batch processing, the MapReduce. So these are the additional ones which we need to work on it. So apart from resource management, Yawn also does job scheduling. Well, I've told you about the concept. That is, when we start with the MapReduce concept, the first and foremost thing which you need to understand here is the job scheduling concept. Because we are having two components there. One is mapping, that is a mapper. The other one is the reducer. Okay. So when we are talking about the mapper, what happens here is we need to assign the resources to the mappers first, so that the first task is completed by the mapper. Okay, until then you cannot assign the resources to reducer. Okay, so the mapper is the one which will try to work with it. So here what is happening? We are talking about the prioritization. We spoke about the prioritization, how exactly the prioritization works on it. Okay, so task prioritization is the concept which has to be taken care. Now, Yarn extends another part, that is, of course, job scheduling. I told you that we are working with the task prioritization, and then we are talking about the way it has been scheduled, okay, based on the priority. Now, Yarn extends the power of Hadoop to other evolving technologies also. So mapper and reducer were one which we had to work out with the task prioritization. Okay, so that is the reason job scheduling is being considered. Now we talk about the additional stuff that is being involved in the Yarn part of it. So what it says, Yarn extends the power of Hadoop to other evolving technologies so they can take the advantage of HDFS. Okay, so to utilize it much more efficiently, we are talking about these particular lines. Now, so most reliable and popular storage system on the planet. That is how you can mention the HDFS. Okay. So as we are trying to work on the different types of data type. Okay. It's not just one that is structured, is basically maximum, that is no unstructured and semi-structured data which you have to work on it. And economic cluster also. Okay. So that is what is the point you have to initially work with it. Now, you can see here we are having Hadoop distributed file system. Above that we had only the MapReduce and tried to perform it. Okay. So what was the change here? We tried to have an additional layer, that is the Yarn, the cluster resource management, what it is called as also. Okay, in a cluster we are talking about the resource management, how well it can work on it, how well it can manage it, organize it. Okay, so the resources, the task, everything has to be taken care, right? So this is taken care by here itself, not providing it to each and every framework. Okay, so when we do this, automatically not just one framework can be implemented, there can be many frameworks which can be taken care over the particular line. That is the point which you need to look out. So what I suggest here is, when you talk about this resource cluster, Yarn resource cluster management, the scenario totally changes. We are not just working with only one particular MapReduce concept. We are working with the interactive, that is TCZ. We are working with the online HBase. Okay, streaming, Storm, then graph we have GIRAF, then in memory we have Spark, then SAS. Okay, and it goes on and on. Okay, so we are having so many things like Spark and other things which can be again worked out with these particular points. Now, looking at this particular feature or the diagram, you can just imagine that if you understand HDFS, if you understand Yarn, you are able to work with so many frameworks easily. That is another fascinating point which you can look out into this particular point. Okay, so what is the main point here? To understand Hadoop distributed file system. The next is Yarn. Okay, how exactly Yarn works out. Okay, now moving on to the next, that is, we'll just define it, what exactly we are talking about. So Apache Yarn is also a data operating system for Hadoop 2.x. So it becomes a data operating system, not just a point where you can just say about resource management. We are talking about the data operating system. It tries to work out with all the features which then OS is providing. So OS and particular Yarn, you can just imagine how it is related and what all advantages it can provide. Okay, so this architecture of Hadoop 2.x provides a general purpose data processing platform which is not just limited to MapReduce. Okay, it enables Hadoop to process other purpose built data processing system other than MapReduce. So when we talk about this particular point, it says that not limiting it to only MapReduce. Okay, that's what I showed you the diagram. So the diagram was suggesting what? We are focusing on multi-purpose. Okay, so there are other purpose, other frameworks, other platforms. All these are been inhabited and incorporated with Yarn so that it can become much more easier to provide the facilities. Okay, so you can just imagine a single layer giving you all these particular details. Okay, how well it has been developed. Yes, so that is what we are trying to learn in depth in the later slides. Now, what here says, it allows running several different frameworks on the same hardware where Hadoop is deployed. So on a single hardware which is situated, okay, on that top of it, you can work with any number of multiple frameworks on it. Yes, what is you want? What does the developer needs there? Okay, you have to just go on exploring it, how well I can develop so many works and complete the task. That is the only thing you have to work. So you have to just go on building the logic. The logic plays a vital role and just to utilize the resources. You need to have a backend, you need to work with HDFS. Okay, you need to work with the front part, you need to work with the programming aspect. Combine it and you're just ready to work with any particular large data set and provide you the applications. So just think of these lines. It is very important an aspect of your future. How well you can develop and how well you can understand it and how well you can be more different from the others by just understanding the concept and also implementing it. A very important point. Okay, do implement it. Just by understanding and just remembering it will not help you. Okay, that is only limited to your exam point of view. You need to work with the implementation so that practically you can work on it. Okay, so Hadoop installation. While installing, you will come to know what all things are there, how exactly it works, what all things to be taken care of. Okay, when you work with any commands, okay, when you work with start all commands, what exactly happens there? Well, the set of windows which get open, you need to check, right from the name node, data node, resource manager, Yarn, Hadoop Yarn manager, all these things are taken care of. Okay, why and how? Of course, that is what we are studying here. Well, this is what it says, not just only one point, it works with many particular aspects. Now, Hadoop Yarn architecture is basically what you can say split up into functionalities. The fundamental idea about a Yarn is we are talking about two things. Okay, the functionality of resource management and job scheduling or monitoring. So you are talking about the management regarding towards the resources, and also you are talking about the job scheduling and monitoring part of it. These are the two major things which has to be taken care. Because once you assign a job, okay, what is the part you have to look at? Well, you have to understand that a job has been assigned, it has to be monitored whether it is completed or not. Okay, well, what is the job given? Okay, you have to make a proper understanding of that so that you'll come to know if that problem definition needs certain equipment, certain requirements. Okay, are those requirements or in bracket resources available for the particular task to be completed? So this is what is the two things you need to look out for. Yes. So of course, job scheduling is having a pattern, as I said, based on the priority. Okay, but the another part is regarding towards the managing the resources, coordinating the resources. How well you are trying to coordinate the resources plays a very vital role. That's why it says as a data operating system. Okay, not just a point of concept. It is a data operating system where we are trying to work with the management of it. How well the resources are being taken care. If that resource is not assigned, what does the task do? Okay, is it starving? Okay, is the particular task waiting? Is the job waiting for the particular resource to be assigned? Okay, if not assigned, what happens? Well, all these things have to be taken care, isn't it? You're not just talking about a particular task which has been given. Is it complete or no? We are not just about no. It has to be taken care right from the start up till the end. Okay, from the beginning up till the end, is it working properly? Are you getting the result? Until then, the monitoring, the process or resource management, all these things have to be taken care. Okay, So that is how you are trying to work with each and every detailed part of it. So you are trying to dive deep into that. Let's check. So these are the two particular functionalities, that is resource management is one, job scheduling or monitoring is another. So which is split up into separate daemons. Okay, so these are two parallel things which can be taken care. Okay, it's not just you have to first job schedule it, okay, and you have to then work with the resource management. No, that was what was happening in the previous Hadoop 1.0 map reduce concept. Everything was allocated to mapper. Once the mapper is done, then the resources are set back, then the reducers will be using it, and then the process starts. Well, that has been totally changed into the following point. This is another advantage and the disadvantage which I discussed. Okay, how well the functionalities are working here. Okay, now the idea is to have a global resource manager and per application as an application master. Okay, an application is either a single job or a directed graph of jobs. Okay, one after another which have been taken care. Now, as it says, we are talking about a global resource manager. Well, why we need to have a global resource manager? Not like the previous one when we had to work out with a particular single cluster. No, there is a small change which you need to understand here. Okay, so when you talk about the global resource manager, the resource manager will be associated to the multiple nodes which are being created. Okay, and each of those slave nodes, okay, which are having the jobs or the task which has to be taken care of or to be completed, they need to have a particular resources which are to be assigned to it. Okay, so all these particular points have been clearly described in the architecture, but I am giving you the introduction part of it here, saying that what all things are to be taken, why it is mentioned as a global resource manager. Yes, so a resource manager global will be able to assign it to whichever nodes which are to be completed. So that is the one which will be sending the request and it will be getting assigned to it. Okay, now what I say here, per application as an application master. So an application master is there which will help you to understand which are the jobs which are to be taken care, because those are specific jobs. Okay, we're not talking only about only one particular job. No, there are specific jobs, specific task related jobs which are to be done. And that is why we are talking about the per application master. Okay, well, this is also associated with another component called as container. I'll come back to that also later. But initially you have to understand that is we are having a global resource manager and per application master. Okay, so these are the 2 points which will be helping us to understand the initial point of the Yawn. Next point what you need to understand here is the resource manager and the node manager form the data computation framework. Okay, so the point here is resource manager and the node manager. The node manager has come into the picture. That's what I said, right? You will be having multiple nodes. Each of them will be managed by a node manager and he will be in communication with resource manager. Okay, and these two actually are trying to complete the computation. That is the data computation part of it. That is why I call as data computation framework. Okay, the resource manager is the ultimate authority that arbitrates the resources among all the applications in the system. Well, we'll be having a particular method. It will be having a particular algorithm in which it will be implementing. That is the arbitrary. The way it has to assign or accept the request of resources and how it will assign the resources to the particular node managers so that the task is being completed. So it is having a particular arbitrary way, maybe an algorithm to be implemented. The node manager is the per machine framework agent who is responsible for containers. That's what I mentioned here, right? So a node manager is the per machine framework. So a particular machine, each machine having a framework who is responsible for containers, okay, monitoring their resource usage. So what is the usage? What is the containers consisting of? It is a particular system consisting of CPU, memory, disk, network. So a container consists of a CPU, it consists of a memory, it consists of a disk. Okay, a small amount of disk so that it can store and work on it. Okay, memory to complete the CPU is the process. So network, of course, the nodes which are connected In the nodes, the applications which are important, because the applications are the one which will use this, because the application is the one which is having the job, the task in it, and these are the ones which has to be executed using the resources. Okay, so these application masters are held in a container. Okay, so the container is connected to the application master and then it works. Well, I'll tell you that later. And reporting the same to the resource manager or schedule. This is how it works with the following concept. Now, the next point what you need to understand is the per application master is in effect a framework specific library and is tasked with negotiating resources from the resource manager and working with node managers to execute and monitor the task. So I told you this just a few minutes back, saying that what exactly the application master is doing. What is the effect of it? What is it doing there? What is happening in that effect? Okay, so the effect what is taking place is basically a framework specific library, okay, and it is having certain tasks with a negotiating resource manager. So these are the operations which has to be done, the functionality. Okay, one, a specific library which will be computing that, and the task so that it can negotiate with the resources to acquire it. That is the job of the application. Okay, so it checks what all resources have been acquired, how exactly it's been performing, is it working, is it alive, active, inactive, all these are to be taken care, and working with the node manager to execute and, as I said, monitor the tasks. This is what is the point you have to note in the Hadoop Yawn architecture. Okay, so this gives you the initial idea about what all things are involved in it. Yes, a resource manager, of course the client, then we have the global resource manager, yes, then we talk about the application, per application, that is the application master, container, okay, node manager, all these are the components in which you are trying to describe the Hadoop Yawn architecture. Okay, now we'll go to the main aspect, that is the architecture itself. So as you can see this, what all things are involved here, as it says two main components, that is one is scheduler and another one is applications manager. Okay, now when I say that it is scheduler and application manager, the point here is we start with client. Okay, so each client is having a color. Okay, why it is colored? Of course it is related to the node manager, which is specific task specific related live, whatever what you can say, basically concept related to each other. Okay, what is the specific task to be completed by the colored clients, and that is the association with the node which are performing those tasks. That is the point you have to make a note of. Okay, now client is there, global resource manager, a huge particular, so what is a square and the rectangle is being depicted, showing it is a global one. Then we have the node manager 1, 2 and 3. Then we have the container, that is 1, then 2. So here container is having the matching color with this, and the container with this is matching with this, and 2 more containers which are matching with this. So each application of course will be having those connection with the containers, because the containers will be having the main specific task associated with it. And what does this application require? The CPU, the memory, the disk and the network, so that it gets connected and then it works with the resource manager to work on it. So let us understand each and every step, because we are trying to understand here the actual concept. So these are the particular things. Of course, very important thing is the arrows. A solid arrow is a map reduce status. Okay, the map reduce is what? The processing of it. Is it completed or no? Based on that. So map reduce status. Then the job submission is a dashed arrow. Okay, that is job submission. Then the node status, status of a node, whether it is active or not, is a blue colored, okay, semi-dashed arrow. Okay, then resource request is a dotted arrow. Okay, so these are the 4 particular things which have to be monitored, taken care of. Okay, now when I talk about these particular points, we'll go step by step. What is the first step? Okay, the first step what you need to understand here is, that is the client. Okay, the submission of the jobs or the files. the client will be sending the set of files and it will be sending to the resource manager to get it associated with that. Okay. Now, once we get it to the resource manager, the second step is basically the application masters, okay, need to be connected to the resource manager. Yes, so that they are working. Before we have this, there's one more important thing, that is getting them registered. Okay, so application master is having a point that is a dotted, but it's just a resource request. Okay, but it is situated under the node manager. So the second step is what? All these node managers are having registered with the global resource manager. Okay, so what is the first thing? You talk about the node manager 1, 2 and 3. All these are having the blue colored arrows. Okay, so it says that you are supposed to register. So what happens when we register? Automatically you get all the privileges to work on it. Okay, so the second is what? The node manager is getting registered to the particular point of it. Next, after that we try to understand what does the node manager, each of them consist. Of course, it is consisting the container, the application master. Okay, so when I say the application master, okay, this node manager is having one, this is having another, and here we do not have any application master, we are having container. So a container may be a single one or it may be multiple. Okay, but whereas the application will be having one associated with it. Okay, so a container for this particular color, that is the pink one, you can see 1, 2, 3 containers are being associated with that. Okay, so that is the third step, working with the containers so that they can understand how well they are being associated with it. Okay, so these containers are associated with this particular application master, and this blue color is associated with this application master. Okay, so once we understand that, the containers in it, the application masters which are involved in it, okay, and the next step is what? The application master which is working with that. So you can see here we are having a solid line. Okay, so all these are having a solid arrow. What does the solid arrow means? The map reduce status. Okay, that is the main designing pattern. What is the job they have to work? So that is what the container and the application master will be performing. Okay, so that is why we are having a solid arrows, that is the map reduce status, which is being provided between the following set of details. Okay, now container is done, application master is done, the association between is understood because we are talking about the map reduce status. Next thing is what? We have to complete the job. So the job submission is done here. We are trying to understand this side of it, got the idea about this stuff. Now once we have the idea, we provide one basic, that is the application master will send a dotted arrow. What is the dotted arrow? The resource request. Okay, this is what happens with two things, 1 and 2. There are 2 which have been sending. Of course, the blue lines, that is the node status, whether it is active or not. Okay, that is to find out. Whereas the actual job, what is happening between them with the solid arrow and the dotted arrows. Okay, so the application master will send a dotted arrow here, and from here it will send it to here. So in this case, what happens? We are talking about how well it will be assigning it, because we have registered here. After registering, we are trying to acquire the privileges, and the job of the resource manager is to just complete the task on that basis. Okay, so the resource manager will arbitrarily perform that task. That is to assign the resources to the application master of this part or application of this color. That is, one is pink, the other one is blue. So how well it has to work, that is left to the resource manager. It will give you the resources, assigning it, and based on the prioritization, it will perform the task, or it will be based on a particular algorithm. It will work and it will give you the resources. So once that is done, okay, what happens is we move on to the next step, that is the 7th. What happens here is the client is also having an arrow here. That is the status of a map reduce. So client is also directly connected. Okay, well here there is no arrow. You can just make a note in the PPT later. That is, from the client an arrow comes and connects to this particular application master. Okay, that is the same job specific. Why that is connected? So that it can keep track. Okay, it can keep the process progress of it, or the status or the record of it, what is happening. Okay, so that is what is the point which has to be connected here. That is the seventh one. So in short, these are the four major steps which has to be taken care. So we'll go quickly with the following points. That is the first point, that is the job submission from the client. Okay, from the job submission it goes here. Okay, once the job is submitted, each of the nodes will be assigned with that. Next, we are talking about a particular point, that is the node which are getting registered with the blue color. Okay, that is the node status. Okay, then the application master and the containers, trying to understand what is the association between them. Then the application master gets registered here with a particular arrow and tries to understand how well you are trying to send the request. Okay, and try to perform that well. There's one more arrow I said, from client to the application master, which will help us to understand the MapReduce status. So within the containers and from client to application master, the MapReduce status will be identified. So this is what is happening in the overall picture. Okay, but I said eight step bucket, right? The eighth step is just to deregister from the resource manager. Okay, why to deregister? Of course, well, you are trying to work with the memory allocation concept. You are trying to work in a very efficient memory allocation concept. So once you deregister quickly, it can be assigned to some other nodes, node managers, and it can perform the task. So this is what is the whole and full concept which has been implemented in the Yawn. So the containers which are associated with each application master and the following color, okay, will help you to understand that they are the ones which will help you to perform the task and get the job done, and the later things are to be taken care by the arrows which are there. So this is the whole concept which is happening in the Yawn architecture. Okay, so I'll just give a small description that is provided here. So I discussed about the details, that is complete architecture of Yawn. So Apache Yawn framework consists of master daemon known as resource manager, okay, and the slave daemon called as node manager. Okay, now so one per slave node and application master, one per application. So that is the point to be taken care. So we have two master and slave daemons having the resource manager and the node manager who are trying to perform it. Next, resource manager, I told you, it is a particular major part of Yawn. So it manages the global assignment of resources, that is the CPU and memory, among all the applications. Okay, so it arbitrates system resources between competing applications. That is the point to be taken care. Then resource manager has two main components, that is scheduler and application manager. So the scheduler is responsible for allocating the resources to the running application. The scheduler is pure scheduler. It means that it performs no monitoring job. It just works with the scheduling, that the job has been scheduled to this and it's done. It doesn't check whether it has been done or no. That is done by the next. So no monitoring, no tracking for the applications, and even doesn't guarantees about restarting failed task either due to application or hardware failure. Okay, that is what the scheduler. Then who does the tracking part? Well, the application manager is the one who performs that. So he is the one who will take care about the managing or running application master in the cluster. That is, it is responsible for starting application masters and for monitoring and restarting them on different nodes in case of failures. So this is the point which has to be taken care. Okay, so with this there are certain advantages, as I said. Okay, the scalability and others, that is what I will discuss in the next slide. Okay, so that will comprise the advantages and also the other details of it. So with this, the Yawn architecture and the other details have been completed. That is the limitation of MapReduce. So what happens in the MapReduce is, you know what it does, how it works. So there are certain limitations which you need to understand. So the points are already listed here. The first one is called as the scalability. Okay, so what is scalability? Well, as and how you want to add up the servers, add on the clusters, it should be adaptable and work on it. Okay, now the Hadoop One architecture provides a restricted level of scaling because of the single machine that runs the job tracker to handle all task tracker node. So what is happening? The scalability is limited in the MapReduce 1, what we discussed. Okay, now the MapReduce model is unable to process the streaming data and in-memory interface operations. That is another point which has to be make a note of. Okay, now a job tracker already has too much responsibility. You know what is the point here? You have to monitor, you have to know active, you have to check the signals and all those things. So all these are responsibilities which are present, and addition of more nodes to the cluster increase the work of job tracker. So this reduces resource utilization, possibility of more node addition, and chances of scalability are less. So these components, okay, are not properly handled because they go on adding the nodes, but are the nodes utilized? We need to check out. Yes, so the scalability is the first particular point to be taken care, because the number of nodes which you are trying to deploy, which you are trying to place, need to be monitored properly. Each and every node which has been scaled up has to be taken care of. Okay, it's not that you are just leaving it out. It's not a proper way of handling it. Okay, then availability. The scope of availability is limited because the job tracker is the only point of availability. That is the only point which tells us, okay, as you compare towards the Yawn. Okay, you can just make out a difference here. Yes? So, and in case if it's fail, what happens? The job has to restart. So the availability is starting with the job tracker because the name node is the one which goes with the next set of points. So this is the point you have to work with, the availability point. Next we have the resource utilization. Well, in resource utilization, what we can say here is, it defines the number of nodes separately to handle the mapper and reducer task in advance. Okay, so what we do here is, how exactly the limitation has been provided. When all the nodes defined for handling mapper tasks are full, you cannot assign a mapper task to a node that has been defined to handle the reducer task. That's what I told you about when you started with the MapReduce concept. A map has, that is what the scheduling prioritization. Okay, how scheduling takes place, what is the prioritization, how it works. Okay, so the task prioritization is very important point here, because the resources which are allocated to the mapper needs to be allocated fully, and they cannot be deallocated until the mapper is completed. Until the whole mapper concept is done, we cannot make any changes. That is, you cannot deallocate it. So what happens? The resources are all allocated to the mapper of one slot. What about the other slot, one who are completed the mapper and who are ready for the reducer? Well, they have to wait. This is what is the another limitation of the resource utilization. Okay, so what it says, this restricts the utilization of resources as the data nodes will sit idle in spite of the availability of empty resources. This is what is the point you have to work on. Last is non-MapReduce applications. Well, that is the last part and the most important thing which has been already depicted in the diagram when we started with the Yawn. Okay, we're not just focused on the single batch processing MapReduce. Okay, we have a lot of things, streaming. We have a lot of things like, what you can say, in-memory interface and all those things which can be managed with non-MapReduce applications. So, Hadoop 1 is designed to do only MapReducing programming concept, jobs. Okay, so the others are not able to handle. So the Yawn will be a platform which will help you to work out with these particular ideas. So this is what it tries to describe and depict. Okay, so these are the certain limitations which you need to focus. Okay, so with this particular point, we'll be completing the whole concept about what is Yawn, what is the architecture of Yawn, what is the working structure of it. Okay, only two things, just apart from the syllabus, that is, I spoke about the installation, right? In that video, you can look out for certain things, as I said, Yawn, resource manager and node managers. Well, these are the points where scheduling takes place. There is a fair scheduling, there is a capacity scheduler. These schedulers will actually help us to work out with the Yawn schedulers. Okay, that is the capacity scheduler and the phase scheduler. Each of these are being highlighted, okay, when we talk about the Hadoop installation. Okay, so when I talk about the Hadoop installation, what happens? We are having certain files, XML files, wherein the property of that has to be changed. You are trying to copy paste certain properties. Why? So that we are trying to use these things. How exactly the scheduler are been performing. Okay, so that is the reason why in installation certain code, okay, tag codes are there, tagline codes, which are to be placed into that, so that you are trying to work with a specific schedulers. Okay, so as we spoke about MapReduce, then we spoke about the core site. Yes, all these are the XML files which are using the particular schedulers to work on. Okay, so there are some more which are inbuilt, and there are some more which you have to do manually. Okay, all these play a vital role so that the whole concept is being implemented and you are trying to work on it. Yes, so this is the main idea which I wanted to discuss in today's video. Okay, so in this session we are talking about these stuff. So the last point I would like to tell here is the advantages of Yawn. So Yawn provides efficient resource utilization. That is the first point, you have to make a note of it. Of course, the available resources are scheduled to perform MapReduce tasks as per the requirement instead of the prior allocation of resources for map and reduce job execution. So efficient resource utilization has been done in the Yawn. Okay. After that, it provides a mechanism to Hadoop 2, through which multiple applications sharing common resources can be run simultaneously. That is another point. Whereas in Hadoop 1, you had to work with only different clusters but a single application working on it. That is one. Then we have another point, that is Hadoop ecosystem. Okay, when I say Hadoop ecosystem, what happens? Run those applications in which the MapReduce is not allowed. Okay, whereas here we allow it. We allow n number of frameworks which can be implemented. The resource management and scheduling tasks of the MapReduce model are separated from the data processing component by Yawn. So the Yawn is a particular what is the important thing which separates, okay, that component, the data processing component in MapReducing. So that is the reason why it has been placed on top of the HDFS, so that we can have n number of frameworks which can be working. So a large variety of data processing tasks and wide range of applications such as streaming applications are supported by Hadoop 2. Okay, the streaming application is not supported by MapReduce 1 or Hadoop 1. It is supported in the Hadoop 2. And last is, excuse me, so it provides backward compatibility. That means application developed by Hadoop 1 can run on Hadoop 2 directly. That is a very important point. So whatever you are trying to perform on Hadoop 2, okay, yes, even the Hadoop 1 can also be implemented on Hadoop 2. Coming to the last point, that is Yawn does not have job tracker and task tracker nodes. Instead, there are two main functionalities. What are those? Job tracker, okay, which are having managing the resources. That is a resource manager, and one more is the job scheduling. I told you about two verticals, right? So those two verticals are what? The functionalities. One is resource manager, the another one is job scheduling or monitoring. These are the two things which are being handled. So with this, I would like to end this particular session. Thank you. Take care.